Okay, let's continue with video for polynomials, notes 21. We've got one more example of the addition and subtraction of polynomials. Let's follow our rule. If the parentheses has nothing in front of it, we can just bring everything down. Oh, here's another one, doesn't have anything but a plus sign in front of it, so I can bring the plus sign down. And then we've got a subtraction, and I'm actually going to highlight that because he's important, isn't he? Subtraction needs to get distributed. So we'll put a little star right there so we'll remember, hey, that's one of those subtraction problems you've got to distribute. So minus 1 times 8b squared is going to be minus 8b squared. Minus 1 times a minus ab is going to be a plus ab. And again, lots of different things going on here. And how do you handle them? Left to right. 3a squares. Here's some more a squares. I don't see any more. 7 total, right? 3 of them and 4 of them make 7 of those. You're just collecting the like terms. Next, let's do these ABs. Keep going, keep going. Oh, there's another one. Negative 5 of them plus 1 of them will add up to a negative 4ab. And let's see here. We've got b squares, b squares, b squares. Oh, 3 of those. 3. I was looking ahead. 3 and negative 7 add up to make negative 4. Negative 4 and negative 8 make negative 12 of those total. And if you need to, take it off into the margin, the number part of it, and do it there. All right, let's continue on with our polynomial section. We're going to be multiplying polynomials now. And to multiply them, you want to use a distributive property. That just means if you've got parentheses, you want to distribute whatever's on the outside of the parentheses onto everything inside. And then finally clean up by combining like terms. On number 10, we're going to notice that we have a single monomial, right? A single term multiplied onto a 3-term polynomial. We're going to start off by doing step number 1. We're going to distribute that 3x onto each piece in that parentheses. And it's going to look like this. 3x times x squared is going to be 3. And then when you multiply the 2 x's together, you get x to the 3rd. 3x times negative 2x. 3 times negative 2 is negative 6. And x times x is x squared. Still following our exponent rules, aren't we? 3x times 4, the 3 times 4 is 12, and the x just comes along. There's nothing else to do on this one. None of the terms match, so they can't be combined, and it is already in order largest exponent down to the constant or to the smallest exponent. On number 11, we've got 2 parentheses, so we're going to distribute the 2 onto the first parentheses and the negative 3 onto the second parentheses. 2 times x is 2x. 2 times negative 4 is minus 8. Negative 3 times x is negative 3x, and negative 3 times negative 1 is plus 3. Now combine like terms. You want to do the x's first. 2x's and minus 3x's is going to equal negative 1x. Writing the 1 down is optional. That is strictly up to you. Negative 8 and 3 are the same kind of term. When I combine a negative 8 and a 3, I'm going to be left with a negative 5. So that's how you multiply polynomials and combine like terms. Let's continue on the next page. On these, we're going to be multiplying binomials together. To multiply binomials together, they have a process called FOIL. The F in FOIL means multiply the 2 first terms together. See, A and C are the first terms. FOIL the O means the outer terms. The A and the D are the outer terms. Inner, we're multiplying the B and the C together. And last, the B and the D. I actually just distribute, but I wanted to point that out because a lot of times you'll hear teachers say FOIL, and this is what they're talking about. All you have to remember, see, I don't use the word FOIL a whole lot. Well, I do, but I don't like to say first, outer, inner, last, only because what if it's not 2 pieces times 2 pieces? What if it's 2 times 3? There's not a special name. They all actually work exactly the same way. We're going to start by distributing whatever is the first piece in the first parentheses onto each term in the second parentheses. So 3p will be multiplied onto 2p. 3p times 2p is 3 times 2 is 6, and p times p is p squared. So 6 and p squared. Now we're going to distribute the 3p onto the negative 1. 3p times negative 1 is minus 3p. See, that's what I mean by distribute the 3p onto everything in the second parentheses. Once you finish with that, let's start with the negative 2. We're going to distribute him now onto the 2 pieces in the second parentheses. Negative 2 times 2p is minus 4p. Negative 2 times negative 1 is plus 2. That's what they call FOIL. So now let's combine like terms. There's only one squared term. There are a couple of p's, negative 3p and negative 4p combined to make negative 7p. And there's only one constant, so you can bring him down. And that's it. That's what combining like terms and simplifying looks like. Now, let's continue with the distributive property, or FOIL. Okay, we're going to distribute everything in the first parentheses onto the second, but we do it one at a time. Start with the 5x. 5x times 3x is 15x squared. 5x times negative 4y is negative 20xy. See the 5 and negative 4 multiply together, and the x and the y. And again, if you have multiple variables, multiple letters in a term, put them in alphabetical order. Now we're done with the 5x, so I'm going to scoot over and I'm going to multiply the 2y onto everything in the second parentheses. 2y times 3x. Well, the 2 times 3 is 6. And I've got a y and an x, but I'm going to write them down in alphabetical order. Now the 2y times the negative 4y. 2 times negative 4 is minus 8. And y times y is y squared. Now check to see if it's in descending order, and in descending order, I'm sorry, I'm reading something I shouldn't have. All right, there's only one term that has just an x squared in it, so that's going to go first. Since I've got multiple letters, I'm just going to go left to right. I've got 2 of the xy terms, negative 20xy and positive 6xy are going to add up to negative 14xy. And we've only got one y squared term, so I'm going to bring him down last. As long as all the pieces get used and combined appropriately, you've got it. Let's look at number 14. Same thing. I've got 2 pieces multiplied onto 2 pieces, right? 2 binomials being multiplied together. And all you have to do is distribute everything in the first parentheses onto everything in the second, but you do it one at a time. Let's start with the x. X times x is x squared. X times 2y is plus 2xy. None of the terms match, so you just put them in an alphabetical order with the constant out in front. Now let's scoot over and distribute the negative 2y. Negative 2y times x is minus 2xy. And negative 2y times positive 2y is a negative 4 and a y squared. Now combine like terms. There's only one x squared term. There are a couple xy terms, but they happen to cancel each other out. And there's one y squared term. Well, that's kind of cool. This is actually a special factoring, and that will be introduced to you as you go on in math. Let's do number 15, and then we may stop there and pick up where we pick up and finish in the next video. Starting with number 15, again, binomial multiplied onto a binomial. So all that means is distribute everything in the first parentheses onto the second parentheses. 3w times 3w is 9w squared. 3w times negative 7, negative 21w. When I finish with that term, I'm going to scoot over and now distribute the 7 onto the second parentheses. 7 times 3w is positive 21w, and 7 times negative 7 is minus 49. After that, combine like terms by adding it from left to right. So let's see, I've got one w squared term. I've got two w's, but they happen to cancel again. And I've got one constant. That's kind of cool. And like I said, that's a special factoring that you may be introduced to later in math. All right, let's stop there. I'll see you in the next video.